And again, as Gabby said, and thank you for the introduction, I'm Brian. I'm a PhD candidate at MIT, and I'm just going to talk to you a little bit about kind of who I am and what I do. And so let me get actually a laser pointer so I can point to things. This is me, as you can probably see. And I was actually born in Jamaica. It's a small nation in the Caribbean and small island. And then I moved to the United States when I was still a child, teenager. I went to high school in the United States. And then somehow I found myself at MIT. During my undergraduate, I studied physics. I had some time where I did work on superconducting quantum computers, and I did a bunch of other experimental work throughout my time there. And so after doing all of this hard work and finishing my undergrad and graduating, I decided to go back to MIT again. And so I'm still at MIT as a graduate student. And so I'm going to talk to you a little bit about what I'm up to now. And so what is my research about? And so like Donnie, I research devices that use light, and it's called integrated photonics. And so this is kind of a good kind of picture of what they look like. They're pretty fancy and they're really, really tiny. That's very important because the way you can think of an integrated photonic chip is that it's just like an electronic circuit, except that instead of electrons moving through it, you have light that's moving through it. And so as you guys have learned throughout your course, we always want to try and, especially when you start talking about devices that use quantum mechanics, you want to try and leverage the wave properties of different quantum systems for a technological advantage. And so that's exactly what we're trying to do using integrated photonics. And it doesn't only have application in kind of quantum computing, it has a bunch of other applications. So for example, things that already use light, you know, if we do the information processing using light itself, which comes as an input, for example, in the sensors on what might be an automated vehicle, it can be much more efficient. Another useful thing of integrated photonics is how tiny it is. So on the left here, I'm showing you, it's a device used a lot in science called a spectrometer. You usually use it to identify certain types of materials, and it's huge. It takes up a whole like table, like normally in a lab. But using an integrated photonic circuit, if you're really, really clever about how you design it, you might get it to be really, really tiny to fit in your hand. And so these integrated photonic circuits are almost like doing Moore's law on anything that uses light. And that's really, really important. And of course, as this is kind of the topic of the course, we can use integrated photonics to implement some types of quantum information processing. And so what I'm showing you right here is actually kind of what would an integrated photonic chip would look like if you tried to implement a C0 gate. And that should be maybe really exciting to some people. And so what do I actually work on? So I showed you this kind of schematic of the implementation of a C0 gate using an integrated photonic circuit. And obviously it takes a lot of work to try and design one of these, but is that what I work on? Not quite. We have to take a closer look at one of these branches. And so in these branches, we're going to send light through, and then we're going to try and alter the path of the light. And that is going to represent our qubit, similarly to what Donnie was talking about. This is still not actually what I work on. So we have to go even further in and look at one switch on this single branch. And obviously there also needs a lot of research into how do you design this switch to alter the path of the light? What kind of signals do you send to it to get that type of control without destroying your quantum system? This actually still isn't what I work on. This is what I work on. This small patch that goes inside the switch, that goes inside the network. It is made of a very specific type of material. And that's what I work on. I design what this material is, what it's made out of, and how to fabricate it, and then how to control it. And so it's kind of just a good example of everything that really goes into these really complicated systems. You can't just like sit down one day and decide to build one of these. It goes down to even just atom by atom, knowing how it works, and from that being able to actually control the whole system. And so like Gabby mentioned, these are called phase change materials. And so these materials help us to control light inside of these networks to do this type of information processing. And while, my knowledge on quantum information and quantum mechanics is very helpful for understanding the system and understanding the context, really my work is on the material itself. And of course, you guys are welcome to ask more questions about it. But moving on, I want to tell you guys a little bit about kind of how I got to where I am. And it's easy to kind of think that it's just kind of this linear path. You study hard, you take math, you take science, and then you go to college and you're somehow now like a quantum engineer. But it's not that simple. There is actually probably a lot of steps going from, being like a baby to being an actual scientist. And it's really, really complicated. And you'll often find yourself like this, and you're simply just thinking. And this is kind of what I want to get across in this talk a little bit today, is that you should take some time to take a step back and think about where you are and where you want to go. I actually did not start out in quantum mechanics or physics at all. And I realized it's a complete missed opportunity. I started out working in an orange juice factory, like actually like taking orange juice and like testing it for bacteria. And so somehow you start from, being like orange juice person by day and kind of like studying by night to then becoming like a real scientist. And there is not only one path to get from where you are to where you want to be. And there is not only one place that is kind of an acceptable place for you to make your contribution. And so kind of with that, I want to leave off just by, oh, sorry, I'm forgetting that, of course, there are other people that that kind of go into contributing to this path as well. Your family, your friends, your teachers, your research mentors, and you don't only go through this journey alone, and you should always keep in mind the people who are around you. And one day you'll probably be finding yourself looking back at people who are, at an earlier stage in their journey, and you should make an effort to help them out too. And so just leaving off, I want to just, say, stay open-minded about where you are, about where you want to go, and about which path that you want to take. There is no preset destination. And so good luck to everybody. And thank you for listening.